Okay, hi everyone. Welcome to Geek Maths. Let's just review 1994 AMC8 question number 21 to 25. Okay, so a gumball machine contains 9 red, 7 white, and 8 blue gumballs. Okay, three colors. The least number of gumballs a person must buy to be sure of getting 4 gumballs of the same color. Okay, so least number he should buy to get gumballs of the same color he's sure to get. Okay, so suppose he's getting a first gumball. Okay, so he's getting, so we have three colors, right? So we have red, we have white, and we have blue. So the first gumball he picks is a red. Okay, assume the second he picks is a white, third he picks is a blue. Okay, now let's go to the fourth. So fourth will be one of these three, so let's again assume red, then 5, then 6, then 7, then 8, then 9. So he has picked 9 gumballs. See, he can also pick 1, 2, 3. That's possible. So, but in that case, he is not assured that he'll only pick red, right? So we are assuming the worst case scenario where he is picking one of each color. Now, when he is picking the number 10th ball, it will come either 10 can come either here or here or here, right? So that will automatically be surely one ball of any of these colors. We already have three balls of each color. So the 10th ball is the one, okay, which will make sure that he gets 4 gumballs of the same color. Okay, so your answer option is 10. Going to the next question. The two wheels shown below are spun and the two resulting numbers are added. The probability that the sum is even is. Okay, now look at this. Okay, be very careful. This 3 is not 1/3, right? It's 1/2. This is 1/4, this is 1/4. So when you're calculating probability of this circle, you need to be careful. In this circle, it is all equal sized. Okay, so that is something for you to note. Just as you see this, right? So the first circle is where 3 is there. Okay, it is 1/2. Okay, remember that. Now, let's start working on this problem. So, for the number to be probability, the sum is even. So, when will a sum of two numbers be even? When both the numbers are even, even plus even will give you even, right? Similarly, odd plus odd will give you even. These are the only two possibilities. Odd plus even plus odd will give you an odd number. So this is the possible. So when you have even plus even, let's see the probability. So here it will be 1 by 4. We have to pick 2. So the probability of getting a 2 will be 1 by 4 in the first one, multiplied by, in the second one we have two evens, right? So 2 by 3. So in the first one, if it is 1 by 4, then 3 by 4 is going to be odd, correct? And in this 1 by 3 will be even, correct? Just the opposite. So this will be 2 by 12 and this will be 4 by 12. Am I doing this correctly? Let's check. No, this is 3 by 12. See, made an error. 3 by 12. So this becomes 2 by 12 plus 3 by 12, which is 5 by 12. Answer option D. Okay, going to the next question. If X, Y, and Z are different digits, okay, so X, Y, and Z are different digits, then largest possible 3-digit sum. Okay, so Z is not there in the numbers given, but Z could be part of an answer. Okay, so remember that. Um, so how do we express this in terms of X and Y? So if you see, in hundreds place I have 1x, in tens place I have 1x, and in the units place I have 3x's, right? So I'm going to write this as 113x. Okay, then I'm going to say plus. What about y? I have nothing in hundreds place. I have 1 in tens place. So I will put a 0 in the units place. So this is 10y, right? So this is how I'm going to express this. So in this, what will be the digits is the question. Largest possible 3-digit sum. So this one has to be the largest possible 3-digit number. That is the meaning. Okay. So now let's check. So for this to be the largest possible number, we have to maximize the hundreds position first. Is that right? So what I'll do first, I'll put a value for x. Suppose I put a value of 9 for x. Okay. Assuming x is equal to 9. What will happen? I will get here 993 plus 10y. Okay, so that is going to make this a 4-digit number. So if I take x is equal to 9, okay, this will result in a, sorry, yeah, okay, 4-digit number. Okay, this is wrong. We don't need this. So now I'm going to assume x as 8. Okay, so now what will happen here? I'll say 8 113 into 8. So that will become, let's try here, 113 into 8. So it will be 4, 2, 8 ones are 8, 10, 0, 1, ones are 8, 9, 904, right? So this is going to be 904 plus 10y. Let me come here, sorry. Yeah, so it's 904 plus 10y is equal to dash dash dash. Again, we have to maximize, right? So if I assume y is 9, again the largest number possible. So this is become 90. Okay, so if I assume y as 9, and now here x is equal to 8, that's what I've taken, okay, for 904. So when y becomes 9, then this will become 904 plus 90, correct? So this will become 994, largest possible number. Okay, now what is this pattern 994? Let's see. 9 is y, so this is y, this is y, and 4 I don't have anywhere. Z is not 4, x is not 4, so this is z. So the pattern here is y y z, which is answer option D, y y z. Okay, going to the next question. A 2 by 2 square is divided into 4 1 by 1 squares. Each of the small squares is to be painted either uh, green or red. In how many different ways can the painting be accomplished so that no green square shares its top or right with any other red square? There may be as few as 0 or as many as 4 small green squares. Okay. Okay. So in this case, I'm going to draw a square like this for 2 by 2 and then divide it into 1 by 1 4 squares. So each of the small squares is to be painted either red or green. So red or green. How many different ways can the painting be accomplished so that no green square shares its top or right with any red square? So green square should not share either its top or its right side with any red square. Okay, so basically green cannot come at the bottom at all, but there are cases that we need to find for this. So first what I'll do, I'm going to say one possibility is all green, right? So we can green, 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 one possibility. So all G, I'm going to put 1. Okay. Now, the other option that I can have is all reds, correct? So, I can have here red, 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 red. So, all are. This is going to become one possibility. Now, let's go for 2 of each. Okay, 2 of each. So 3 of each, because I have already taken 4 of each. Now we'll come to 3 of each. So if I have to have 3 R's, okay, so where will the green go? The green cannot share its top or right with any square. So the green has to be on top, and it cannot share its right with the red. So the green has to be here, right? So it should be green here, and then we will have red, red, red here. So the green is only sharing its left and bottom with the red. So this is one possibility. Okay. So I'll say 3 reds. So this is one possibility. Now let's take 3 greens. What's the possibility? So if I take 3 greens, okay, so shares its top. So green has to be at the top too. Now for this, the green, one of the greens, the green should be at the bottom, correct? And it should not share its right with the red. So the green has to be here, correct? And the red has to be here. Then it's only sharing its left with the red, right? So 3 G's and 1 R. This is also possible. So I'll say 3 G's. This will be again one possibility. Now let's go for 2 reds and 2 greens. Let's see what happens. So 2 greens, obviously the greens have to be at the top because they cannot share their top with the red. So I'll put 2 greens on top, 2 reds at the bottom. This is one possibility, correct? Now, what is the other possibility? Um, if I put a red here and a red below it, okay? Now, green cannot share its right side with the red. So, the green can share its left side with the red. So, I can put 2 greens here. This is possible, right? So, there are 1 and 2 possible ways of 2 reds and 2 greens. So, I'll say 2 reds and 2 Gs. There are 2 possible ways. So, totally 1, 2, 3, 4, 5, 6, right? So, totally 6 ways. Answer option B. Okay, so these are the different ways in which you can put. Going to the next question. Find the sum of the digits in the answer 99999 into 44444, 94 times 94. Okay, 94 times. Little tricky but doable, because these are all pattern problems. If you get multiplications like this of same number, should understand that it's all will come into some pattern or the other. So first let me just multiply 1 9 by 1 4. That will give me 36. I'm going to add up the digits because they want the sum of the digits, right? So I'm going to add up the digits. 6 plus 3 will make it 9. Okay. This is sum of digits. Now let's check 99 into 44. Okay. So what is the value of this? Let me just quickly calculate and come back. Okay. Okay. So this is 4, 3, 5, 6. This is the multiplication. So let's see the sum of numbers. 6 plus 5 11 plus 3 14 plus 4 18. Right? What is the sum of the digits? It's 9. Similarly, if I'm going to do 999 into 444, okay, and whatever number I'm going to get here, if I sum the digits, it's going to give me 27. Again, totaling 9. Okay, so this is the pattern that is going to be followed. Okay, so we want the sum of digits. So in the first line, it's 9 into 1. Sorry, 9 into 1. Second line is 9 into 2. Third line is 9 into 3. Similarly, if I keep going like this, the sum of the digits in the 94, this is 94th line. So this will be 9 into 94. Okay, that will be the sum of the digits. Correct? So that's going to be 9 fours are 36, 6, 3, 9 nines are 81, 82, 83, 84, 846. That's your answer. A. 846. Clear? Because 94th line, again the sum will be 9 into 94. That will be the value here. Sum of the digits will be that. Thank you.